Hi guys, it's Mrs. Tucker. This is the first review for the common assessment that's coming up next week. It's our second 9 weeks common assessment. This is the first review. All right, so let's get started. Here's the first question. It says Linnea can walk 3 miles in 45 minutes. At this rate, which of the following equations can be used to determine how far she can walk in 85 minutes? I'm sure by the time you're in the 8th grade, you guys have figured out the old tax tests and the new STAR tests, and you're even seeing it on your unit tests. Sometimes they don't want to know what the answer is. They want to know, how did you get the answer? Which one of these equations would you use to get the answer? Okay? The first thing I want to point out to you guys in this problem, there's a special set of words they used right here. At this rate. And anytime in any problem, they tell you at this rate, basically it's clue words that you can set up a what? A proportion. Yeah. Clue words that you can set up a proportion. So at this rate, or they say if the rate stays the same, that's clue, that's verbiage that's telling you secretly, let's go ahead and set up a proportion. Okay? So let's do that. I'm going to compare miles to minutes. And if you guys know me, I always set up a word ratio first so I can get all my numbers in all the right places. So let's set up a proportion. Let's start with this. She can walk 3 miles in 45 minutes. Miles goes on top, minutes goes on the bottom. It says, at this rate, which of the following equations can be used to determine how far she can walk in 85 minutes? Where does 85 minutes go over here? In the numerator or the denominator?
Denominator.
Yeah, denominator. 85 goes down here. Did you guys see that they're using D for distance? I'm going to put D for distance right here. Now, here's my proportion. Does what I have set up look like anything they've got up here? No. And you know, the thing that I noticed, doesn't this say D equals, D equals, D equals, D equals? They gave us an equation. We set up a proportion. All of our D's are being divided by what? Our D is being divided by 85. Do you know that you guys can undo division by 85? How do you undo division by 85? What undoes division? Multiplication. If I multiply by 85 over here, oh no, I'm going to make it 85 over 1. If I multiplied these two fractions together, tops times tops, bottoms times bottoms, won't these two cancel each other out? But since it's an equation says what you have over here is the same as what you have over here. And if you're going to multiply this side over here by 85 bricks, you better multiply this side over here by 85 bricks, or 85 of whatever it is you're multiplying by. So if I multiply this side by 85, guess what you have to do over here to keep the whole equation balanced? You have to multiply it by 85 also. That gets rid of all of this here. Now does that help you find something that looks like the right answer? Which one did you pick?
C.
Yep, it's C. Yep, it's C. Let's take a look at 2. The table below shows the cost for mailing a first-class letter with the United States Postal Service. The cost depends on the weight of the letter, so I have cost here and weight of the letter over here in ounces. It says write an equation that represents the data in the table. If you guys remember back to when we were writing equations, we set up a table, and we made sure in the center we had a process column, like this. and we called this side X, and we called this side Y, and I told you guys your goal is to make your X's do what each time? Increase by what? Yeah, your goal is to make all of your X's increase by 1. And I told you if you can do that, then you look at what? How is your Y's changing? What's the increase or decrease in your Y? So that's what you guys need to do next. My change in my X, it's always increasing by 1. What's the change in my Y's? What's happening with the Y's here? Are they going up or going down? Going up by how much? Going up by what? 23 what? Dollars? Oh, 0.23? Does it happen each time? Yeah. The cost of a stamp is going up 23 cents for each ounce. So now my little trick for you guys, do you remember the little trick? Take the change in your Y and park it where? Yeah, right here. 0.23, 0.23, 0.23, all the way down the line. And what do you do next? Times it by whatever your X values are. Yep. And then we look to see if that gives us the answer, and if not, we're going to add or subtract an adjustment. Well, 23 cents times 1 is 23 cents. How do we change it to 37 cents? 23 cents plus what gives us 37 cents? Plus 14 cents? Does that work here? What's two groups of 23 cents? 46 cents. 46 cents plus what gives you the 60 cents? Yeah, 14 cents. Can you write the equation now? Y, or your cost, that's your cost, Y equals what? 0.23 multiplied by what? X, then what? Plus 0.14, where X represents what? The weight. Yeah, weight of your mail in ounces. That's exactly right. Part B says, what would it cost to mail a letter that weighs 6 ounces? You know, I think I'm going to have to change this because it's real easy just to add 6 here, right, into your table. It's easy to add 6 ounces and do what with this number here? Add another what? Yeah. But what if they wanted the cost for a 22-ounce package? Then you're going to substitute 22 in for what here? Yeah, you'd put 22 in for there, multiply, and then add 14 cents. Yeah, I may have to change this number for the future because putting 6 in your table is just real easy to do. And somehow I think those tricky star people aren't going to make it that easy. What do you think? They're mean? Did you hear that, y'all? Star people are mean. Okay, this one right here, I'm going to read the question. I'm going to pause the video. I want you to work the problem, and I want to know how many different ways did we get people to work this problem. On a map, 2 cities, I take a ruler, and there's 2 cities, and I measure out the distance with a ruler, and they're 5 3/4 inches apart. It says the scale on the map shows that 1/2 inch represents 3 miles of actual driving distance, or actual distance between the 2 cities. What's the actual distance between these 2 towns? I'm going to pause the video. I want to see how you set this up. Okay, so we had this nice little discussion about the scale on this map. And one of my little smarties over here said, basically without saying it, but I know what he was saying, he said, I don't want to deal with that fraction. I don't like that fraction of 1/2 inch represents 3 miles. So instead of using 1/2 inch to represent 3 miles, what he said is, let's just double this. Let's use a full inch. That would have to represent what? If each half inch is 3 miles, half inch plus a half inch is a full inch. So 3 plus 3 has to be 6. So let's use that for our scale instead. And we can set up a proportion. Where would 5 3/4 inches go? In the numerator or the denominator? Numerator or denominator? Numerator. And Eli changed it to decimal form. He said, I'm going to call this 5.75 and put x down here, the regular distance. How do you solve a proportion? You cross multiply. 1 times x is x. We're going to take 6 times 5.75. You do the math and tell me what the answer is. The units are going to be in miles. Oh, by the way, did you guys see there's an answer bank here? There is an answer bank at the end. You tell me what the answer is. What's the answer?
The answer is 34.50 inches.
Did you hear that? Because I'm not repeating it. Okay, here's number 4. Number 4. An outdoor swimming pool costs $8 per day to visit during the summer. There's also a $25 yearly registration fee. You only have to pay that registration fee once, and then it'll cost you $8 a day to get in. It doesn't matter how many people you bring, it's just $8 a day. But up front, you have to pay that one-time registration fee. So it says write an equation to determine the cost C, for D, the number of days that you swim during the year. Can we just go straight from the words and write the equation? Have we gotten to that point yet? Can we say the cost C equals what? What was your upfront fee? $25. And in addition to that, so that's your plus, it's going to cost you what? $8 a day. So do I just write 8? 8 times what? 8 times D for the number of days that you go, right? So if I go 3 times, it's going to be 3 times 8. That's 24 plus the initial registration fee of $25. I'm hoping that we all can get to that point where we can take the words and change it into an equation. Raise your hand if you feel like you had an okay time writing the equation for part A. Raise your hand. I want to see. Are you okay with that? Oh, I'd say that's about half the class. We're getting there. It says part B, is the total cost proportional to the total days visited? Why or why not? Why or why not? Proportional. Does anybody remember all of that work we did on, is it proportional or is it not proportional? We did it from tables, we did it from graphs, we looked at equations, and I'm guessing nobody remembers. Does anybody remember anything about looking at data or equations or graphs and knowing if it's proportional or not? Oh, you didn't? I thought you raised your hand. No? Okay, here's what we're going to do. Let's build a little table. It's going to be a small little table. Here is the number of days, and here's the cost. What if you go swimming for 1 day? It's going to cost you $8 for that 1 day, plus your $25 registration fee. That's going to be 25 plus 8 times 1, which gives you what? 33. What if you go swimming for 2 days? $2 days at $8 a day, that's $16. What's 16 plus 25? 41. Now that you have a couple of data points in a table, how do you tell if the data is proportional? Yeah, cross multiply. I wasn't watching the time on that one and I got cut off there. So what we were talking about was the fact that when I put data into this table and checked my cross products were not equal. I get 66 here and 41 here. So now you can answer the question, is the total cost proportional to the total days visited? Well, no. Why or why not? One answer would be when you check cross products on your data, your products weren't equal. Now, just as a reminder, I want to show you guys, if we were to graph this graph, I mean, if you had 0 days, if you had 0 as your X value or your initial day, your initial fee was $25. So if we graph this, my first point would be here, and then each subsequent day, my data would increase by $8 each day. Do you guys remember when we were graphing this? We said that if the data was proportional, your graph would pass through what? Right, down here at the origin. If your data is proportional and you graph it, then your graph passes through the origin. This was our graph. It started for 0 days, our initial cost was $25. If you were to graph it, you could prove it that way, that your graph didn't pass through the origin. Okay? We'll talk some more about this before Common Assessment. Let's go on. Okay, number 5. Which of the following sets of ordered pairs represents the graph below? Okay, what you guys need to do is find points on this line where your ordered pairs are whole numbers. So you can write some ordered pairs, some X comma Y ordered pairs. And I think I'm going to start right here. The X value there is 0, and the Y value there is -2. And I'm going to go see if I've got any X values in my table of 0. There's a 0 there. There's a 0 there. Oh, there's a 0 in each one of these. I found a 0x. I'm looking for a Y value of -2. Well, that one's 0, so that's not going to work. That one's 0. That doesn't work. This one's -1. It has to be -2. That one's not going to work, so your answer here is D. Okay? Usually they're not this easy. There are usually 2 of them that would match this. Okay? That one was an easy one. Number 6, which table is represented by the equation y equals 3 times x minus 2? You know, the one thing I notice about this table, just kind of looking at all of these tables have an x value of 1 except for this one here. It's missing. Okay, so why don't we pop in an x value of 1? It says y equals 3 times whatever your x is and subtract 2. So let's put in an x value of 1. 3 times 1 is 3, and 3 subtract 2 is what? 1. So anywhere my x is 1, my y had also better be 1. Okay, it doesn't work out here. I need an x1 and a y1. Well, that's not going to work, so it's not A. x1, y1. Nope, that one doesn't work. A y of 5 doesn't work. I don't have a 1 here. Here I've got x1, y1. It could be this one, but I don't know. It could be this one also. I don't know what my values are here. It's kind of like they left 1 out. So I'm going to see if I can't put 1 back in this table. Here, I'm going to subtract 1, subtract 1, subtract 1, subtract 1. From 2, I'm going to subtract 1 and get 1. I'm going to follow the pattern here. Increase by 2, increase by 2, increase by 2, increase by 2. I'm going to take -3 and increase it by 2, and you get what? -1. So if I were to put it in the table, it'd be 1 comma -1, but I needed 1 comma +1. It can't be C. It has to be table D. Okay? Let's look at 7. Bill sells firewood Bill sells firewood during the winter. He charges $45 per load of firewood and $15 per hour to stack the wood. Last week, he sold 15 loads of wood and spent 12 hours stacking wood. How much money did Bill earn last week? Okay, well, the question is, how much did he earn? I want a final dollar amount for his total earnings. And it says he charges $45 per load of firewood. Okay, so it's $45 times the number of loads of firewood. I'm going to call loads of firewood F. And, did you know that and means addition? And he charges $15 per hour to stack the wood. So I'm going to call that 15 times H, $15 per hour times the number of hours, and that's going to give us our final, I'm not going to call it cost, I'm going to call it E for earnings. Okay? So last week he sold 15 loads of wood. That goes in right there. And he spent 12 hours stacking wood. That goes in right there. Can you guys finish it? I think you can. Final answer is going to be in dollars. You guys know you can pause the video anytime you need to. Write the equation that represents the data in the table. I didn't say what number 7 was. You were supposed to come up with the answer. Okay, I'm going to rebuild this table because I'm going to use that little trick that Mrs. Tucker taught me. Mrs. Tucker said, my goal is to make my x's increase by 1 each time. So I have -1, and then it jumps to 2. So I skipped some values here. I skipped 0, I skipped 1, and then I jumped to 2. If an x is -1, my y is -1. If my x is 2, my y is -7. And then it jumps to 5. So it skipped 3 and 4. Here's 5. 5 is -13. See ya. From 2 to 5, that was an increase of 3. From -7 to -13, from -7 to -13, are you increasing or decreasing? Yeah, from -7 to -13, that's getting smaller. It got smaller by how much? Yeah, we subtracted 6. -7 subtract 6 more gives you -13. So now I know what the change in my y was. Each time my x increases by 3, my y decreases by 6. What if I only want my x to increase by 1? If x increases by 1, my y should decrease by how much? Yeah, it should decrease by negative what? Or it should go down by how much? Instead of going down by 6, it's going to go down by 2. Let's see if this works out. If I'm at -7 and I get 2 smaller, I'm at -9. If I'm at -9 and I get 2 smaller, I'm at -11. And if I'm at -11 and I get 2 smaller, I'm at -13. So do you see the pattern here? You can work it backwards if you want to now. Increase by 2, increase by 2, increase by 2. So here at 1, I'm going to increase by 2, and I put in what number here? -7 increased by 2 is -5. I'm going to increase that by 2, and I'm at -3. And if you increase that by 2, I'm at -1. Okay, so I filled out my table, and I did what Mrs. Tucker told me to do. Make those, values of x increase by what each time? Yeah, we want them to increase by 1. All right, now that they're all increasing by 1, I want to find out what the change in my y's are. Each time my x's increase by 1, my y's are changing by what? Yeah, they're decreasing by 2 each time. And I know I can take that number now and put it right here. Minus 2, minus 2, minus 2, minus 2, all the way down the line. What goes next? Yeah, multiply by your x value. Multiply by -1. Multiply by 0. Multiply by 1. Multiply by 2. Is -2 times +2 equal to -7? No, it's equal to -4. What do I have to do to -4 to change it into -7? Yeah, I'm going to have to add -3 to it. -2 times +1 is -2. They say the answer is -5. What do you have to add on to that to change it to -5? Yeah, add on a -3. -2 times 0 is 0. How do you change 0 into -3? Well, you might say subtract 3. Did you know adding a negative is the same as subtracting? Yeah. Our equation turns out to be y equals -2 multiplied by, where'd these numbers come from? Yep, those are our x's, and then we're going to do what? You can either call it add -3 or you can call it subtract 3. And we wrote our equation. Y equals -2x minus 3. Number 9. Michelle likes to drive her new car. She has been recording the following data about her road trips. Question 1. What is Michelle's average speed? Speed is, when you're driving, miles per hour. Another way to write that is miles per hour. Here I have miles, here I have hours. 195 divided by 3. Here I've got 260 divided by 3. Here I've got 325, not divided by 3, divided by what? Now, you guys weren't here to correct me. Divided by 4. 325 miles in 5 hours. This is miles per hour, miles per hour, miles per hour. Divide those out and let's see what you get. This one here, I got 65 miles per hour. You do it. Are they all the same? You do it and tell me if they're all the same. Okay? So I want you to decide, once you figured these all out, just make sure that, you're getting the same number. Figure out what her average speed is. Then they want you to write an equation to represent the data in the table. That's real easy to do once you know the speed. You can make one of these. This is your hours. This is how far you drove. Let's call it miles. 0 hours, 1 hour, 2 hours. If you know the speed, you can fill out the table. Look for the change in your y's. Put that number right here. Multiply by your x's, and you will have your equation. Then I want to know, is the total cost, that should be total miles, is the total miles, I'm writing that in the wrong place. Let me fix that. Is the total miles proportional to the total hours? Someone told me there was a typo, and yes, there is. I want to know, is miles proportional to hours? Why or why not? You're going to take this number right here and multiply it by that answer there. You're going to do cross products. And then you're going to take this number right here and multiply it by this number here and check to see if your cross products are the same. Or you could graph it and see if your graph goes through the origin. All right? Number 10, Chris is raising money for cancer research. Write an equation that represents the data in the graph. Okay. We are just going to set up a little table because this right now is the way you guys know how to write equations. Okay? And here's our x values, which are going to come off of here, and here's our y values, which come from over here. And we're going to find points on the line. And you can even pick other points that I haven't even labeled. For instance, like this one right here. Okay? 0, 0. This one is what? 2, what? 2, 15. This one here is 4, what? 4, 30. And then this one is 6, what? Added in here. I told you your goal is to make your x's do what each time? Yeah, they're supposed to increase by 1, but right now they're all increasing by what? They're increasing by 2. And each time your x's increase by 2, your y's are increasing by how much? Yeah. Every time your x increases by 2, your y increases by what? If I made my x's increase by 1, my y's would then increase by how much? Yeah, it's got to be half that amount. So I want you guys to go ahead and finish filling out this table. Bye. Put these numbers in here. Find out what your change in your y's are now that your x's are increasing by 1, and put that number right here. And then multiply it by your x's and see if there's an adjustment. Okay? And then you'll be able to write your equation. Once you have your equation, you can use it to determine how much money can be raised if Chris walks for 25 miles. You'll just plug that into your equation because your x value is your number of miles. Is the data proportional? Why or why not? I can answer it right now based on looking at the graph. Can you? If not, what you're going to do is, when you fill in this number right here, take 1 times 15 and compare it to the product of 2 times whatever this number is here. And you can do it all the way down the table. If your cross products are even, or if your cross products are equal, yes, it's proportional. If not, no. Number 11, Jimbo's job at Target pays according to the graph below. Write an equation that represents the data in the table. You're going to do the same thing here that we did in the last problem. X, Y. X is the number of hours. Y is the amount of money. Pick points off the, there's more points here than what I've listed for you. Like at 2, you get 20. At 4, you get 40. At 6, you get 60. At 8, you get 80. Build your table. Write your equation, your process, your rule right here. That's going to give you A. Pick your points off it's like 0, 0. This is 2, 20. Okay, keep going. Answer the next question. How much will he get paid if he works 150 hours or 150 minutes? Now be careful here. I just noticed. It says 150 minutes, but this is in hours. So you're going to have to do a little converting on that one. And then answer the question, is the total pay proportional to the number of hours worked? Why or why not? I can tell from the graph. You might have to do cross products in your table. Don't use 0 though. Use any numbers like 1, 2, 3, 4 to do your cross multiplication to see if it's proportional or not. Don't forget, right here you're going to have to convert because that says minutes, but my equation is going to be in hours. Bye. Number 12, write equations for both lines. You're doing the same thing you did on the last 2 problems. Start with the first line here. Start with that point there. 0, 0. Put this one in. Down here, 2, 6. Do you see how I left a space for the number 1? 4, 12. See, I left a space for the 3. Do the whole thing where you figure out what your process is so you can write the equation. And then do the same thing for this line over here in this table here. That point there is 0, 10. This point here is 2, 14. I left a space, so you can put in a 1. 4, 18. I left a space, so you can add the 3. This is your challenge question. See if you can write the equation for both of those lines. Number 13, 2 female math teachers at Bear Branch Junior High who specialize in 8th grade mathematics are having a weight loss competition. The table below shows their results so far. Graph the data and determine which teacher shows a proportional relationship between her weight lost and the number of weeks. Use a ruler. Okay? Well, the amount of weight lost depends upon how many weeks they are in the diet. Your dependent variable always goes on the y-axis. Your independent variable goes on the x. And the amount of weight loss depends upon how many weeks you're in the diet. So weight lost goes here. And number of weeks goes down here. And we're going to start at 0 on both scales. 0, 0. Okay? And the weeks go 2, 4, 6, 8. So there's 1. That's going to be 2. There's going to be 4 because there's 3. Here's 6. Here's 8. And let's see, the weight loss, the maximum weight loss goes up to 11. Let's see how many lines we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so each line is worth 1 pound. So let's write pounds here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The top line's 11. I want you to graph Miss Hensley. Okay, at 2 weeks, she lost 3. Here's 3 and a 4th. That's about right there. At week 4, she lost 6 pounds. At week 6, she lost 8.4. That's about 8.5. That'd be right about there. And at week 8, she lost 10.4. That's almost 10.5. That'd be somewhere in there. Now use a ruler to connect the dots with a line. You could grab a different color pencil or something else and then graph the same thing. Number of weeks versus Mrs. Tucker's weight loss. Graph these ordered pairs. Once you have both graphed on the same graph, tell me which teacher shows a proportional relationship between her weight lost and the number of weeks, and I'm going to want to know, how'd you know? If it's Miss Hensley, why do you think that? If it's Mrs. Tucker, why do you think that? 14. Marshall bought 2 stereo speakers that cost $129 each. You know what? If I'm going to buy 2 speakers that cost $129 each, I know I'm going to take $129 and multiply it by 2. The tax rate was 8.25%. Which equation can be used to find C, the total cost of the speakers including tax? Once you figure out your tax amount, what do you do with it? Do you add it to the total or subtract it from the total? Yeah, I spent, that's about 130, and 2 groups of 130 is about 260, so it's a little under $260, right? It's like $258. When you figure out what your tax amount is, you're going to be adding that on. So is there something here we can eliminate? Because I don't see the addition of the tax. Yep, right here. We can eliminate A. We're not adding on the tax there. All right. Let's see if we can find in these equations what looks like this tax percent right here of 8.25%. Right here, let's see, we crossed that one off. This says 0.0825. This says 8.25, and this one says 0.0825. Okay, well, let me tell you guys something. A percent always means out of 100. You never multiply by a number in percent form. If you take 8.25, throw out the percent sign, you have to put it over 100. And 8.25 divided by 100, well, dividing by 100 moves your decimal point 2 places to the left. So this is the same as 0.0825. Okay? This is a number you can multiply by. If you want to set up percent proportion, here's what it looks like. Let me just show you that if we said, okay, that's the same as part, your tax part, over the whole amount, you would set up a proportion like this. How do you solve for your tax amount? How do you undo division by, well, I said 130. It's really, my total here is actually going to be 2 times 129. How do I get t by itself and get rid of division by 258? Yeah, I got to multiply both sides by 258. So my tax amount turns out to be, well, if I take 8.25 and divide by 100, I get 0.0825. That's shorthand for this right here. Let me just even erase it. Let's call this 0.0825. All right, the fraction's gone, we turned it to decimal form. I want to get the tax amount by itself. How do I undo division by 2 groups of 129? Yeah, I'm going to multiply by 2 groups of 129. And what you do to one side, you must do to the other. So I'm going to multiply by 2 groups of $129. And when I do that, that goes away and it cancels out with that. And my amount of tax that's going to be added on is this. Does that show up anywhere in any of these equations? 2 times $129 multiplied by the tax rate in decimal form. That's that one right there. So our answer has to be what? Yep, this piece right here is this right here. Here is the total cost of the 2 speakers. Here's the cost of the 2 speakers multiplied by your tax rate. It's got to be D. Number 15, Jay knits scarves to sell at a crafts fair. For each scarf, she charges $7.50 for yarn and $4 for each hour spent knitting the scarf. Jay uses the equation below to calculate P, the price of a scarf, based on H, the number of hours it took to make the scarf. Your P, your price, is $7.50, the amount for the yarn, plus $4 per hour, multiplied by the number of hours. How much will Jay price a scarf that took her 6.5 hours to make? That's your H. H equals 6.5 hours. That's the number you plug in right there. Multiply by 4. Take that product and add $7.50 to it. And then you'll have your answer. Okay. We've never really talked about this before, and I want to talk some more about it. They gave you the equation. 6x plus 2 equals 2x plus 10, and they've modeled it below. What's the value of x? Well, think of this as a teeter-totter, and this is your pivot point. Whatever you remove from one side, you have to remove from the other, okay? If I get rid of 2 singles right here, if I subtract 2 on this side, then guess what I better do on this side to keep the whole thing balanced? Yeah, I better remove 2. So if I subtract 2 from here, I get 6 times x equals, on this side, I get 2x plus how many left over? Yeah, plus 8. What's the next step? Okay. So we've got 6 x's over here. We're left with 2 x's over here plus 8 singles. How about if I get rid of 2x's here? Let's remove 2x's on this side. Guess what you have to do over here to keep this whole seesaw teeter-totter thing balanced? Yeah, you're going to have to remove 2x's over here. Subtract 2x's over here. Now I have what? Yeah, I have not 4. Yeah, I do. I have 4x's over here equals 8. And I bet you know what x is worth now. 4 times what gives you 8? Yeah. But let me show you back here how you do that with what's left over here. With everything that's gone, I don't have any more x's I can get rid of on this side, so I can't get rid of x's over here. I need to know what each x is worth, and I have 4 of them. So what's left over here has to be divided up into 4 equal groups. So if I take, I'm going to group these up. That's one group of x, one group of x, one group of x, one group of x. I have 4 equal groups over here. I better have 4 equal groups over here. 1, 2, 3, 4. How many's in each group? Yeah, 2. Each one of these x's is worth 2. If you go back down in here, how do you undo multiplication by 4? You divide by 4. I'm going to take those 8 singles, divide them into 4 groups, and I have how many in each group? Yep, I've got 2. We're going to practice some more modeling of those kind of equations, because this right here is what you're going to be doing where? Yep, you're going to be doing it in Algebra 1 next year. Okay? And that wasn't so hard, was it? Well, if it was, we'll practice some more. 17. The table shows the relationship between the age of a mature cat and its corresponding age in human years. Write an equation that represents the data in the table. I don't know if you can tell if there's a direct relation. Let's see, that would be multiplied by 12, but that's not. So let's go ahead and set ourselves up a little table. Are my x's increasing by 1 each time? Yes, perfect, just like we want it. What's my y's doing? They're increasing by what each time? Yep, they're increasing by 4. So I'm going to take that change in the y and park it right there. What am I going to do next? Multiply by what? Yeah, we're going to multiply by the x's. 4 times 5 is 20, but they say the answer is 36. What's the adjustment I'm adding on? Yeah. You write the equation that represents the data in the table. Then once you've got your equation, it says based on the information in the table, what would be an approximate human age for a cat that's 13 years old? Once you know that, this is your x. Remember, the mature age of the cat is x. You could plug that into your equation. Of course, you could finish filling out the table, but who wants to do that when we know algebra? Number 18, which equation best represents the relationship between x and y in the table? Hey, they give you all kinds of x's that you can plug in, test out to see if you get those y's as an answer. So every place there's an x, drop a number in from your table. Pick any number you want to. I decided to pick 10 because half of 10 is what? And then add 4 to it. Half of 10 is what? Then subtract 2 from it. 2 times 10 is what? Add 4 to it. 2 times 10 is what? Subtract 2 from it. Which one of these gives you 9 for an answer? Then once you think you know the answer, try another number. Drop another number in for x and see if you get back that number for your y. Number 19, if the 2 triangles below are similar, do you guys know the symbol for similar is this little squiggly line? You better know that symbol. Okay? If the 2 triangles below are similar, what's the length of xy? This length right here. Well, if they're similar, side lengths are proportional. Set yourself up a proportion. Don't forget your word ratio and start filling in the blanks. This little guy right here is in the small. So put x right here. X in the small corresponds to what in the large? Yep, that's 72 feet. Go back to the small. The only other number you have is 18. 18 in the small corresponds to what in the large? Yep, now you're going to use cross products to solve. You might want to see if 18 over 108 reduces first, but that's how you're going to get your answer. Good luck with this, guys.